Chapter 19, Part 2, Wave Description. We start by trying to understand the meaning of a wave. You can think of a wave as a disturbance that is moving or propagating or spreading from one place to another without actual movement or transport of matter, which means that a wave is not matter. A wave is not made of atoms. A wave is a disturbance that's propagating in space. Examples of waves: light and sound. Now, all waves, as they move, they carry energy with them. How do you make a wave? Waves are produced through vibration. Something has to vibrate to make a wave. For example, how do you make sound on a musical instrument like guitar? Well, you just hit strings. Strings, they vibrate, and this vibration generate sound. Let's talk about wave description. How do you describe a wave? Let's look at the picture of a wave. A simple wave is called the sine wave. Now, if you look at the wave, this curve, the green one, you will see high points and low points. The high points are called crests, and the lower points are called troughs. Amplitude. Amplitude is the height of the wave from the midpoint. If you look here at the shape of this curve, so amplitude is really just the height of the wave as measured from the middle line. Wavelength. Wavelength is distance from one crest to the next, or from one trough to the next. So wavelength is a distance which is measured in meters. Sometimes we will measure it in centimeters or even millimeters or smaller. It depends on how big is the wave. An important concept or term is frequency. Now, what's a frequency? When you think about vibrations, one vibration, one cycle has a unit of time which we call the period, and we discussed this in the last part. Now, frequency means how many cycles in one unit of time, which is second. So how many cycles generated in 1 second? That's frequency. When you think about a wave, so a wave, as the wave moves, how many waves are coming to you as observer, hitting you in 1 second? How many complete waves in 1 second? Now, in vibrations, one cycle is a complete back and forth vibration. Now, if you have only one cycle per second, then the frequency is 1 cycle per second. If you have, let's say, 10 vibrations or 10 cycles in each second, so the frequency will be 10 cycles each second. Now, always the frequency of the vibrating source and the frequency of the wave that's produced by this source are the same. We measure the unit of frequency in units of Hertz. For example, if you have a frequency of 1 cycle per second, so we say that the frequency is 1 Hertz. If the frequency is 20 cycles per second, so the frequency is said to be 20 Hertz. If the frequency is very high, we can use sometimes kilohertz, megahertz, gigahertz to measure frequency. Let's look at this example. You have here a tower, and at the top of the tower there is antenna. Now, antenna is just a metal bar, and there are electrons, free electrons, they move. Now, as these electrons vibrate with some vibration. For example, in this, if you read this example, it says that the electrons are vibrating at 960,000 times each second. Now this vibration will generate waves. We call them electromagnetic waves. In particular, we call those waves radio waves. And the frequency of these waves should be the same as the vibration frequency of the electrons. So the frequency of the wave should be also 960,000 hertz, or call it kilohertz. Remember, kilo means 1,000. As to do some math, now, if you know the period, you can calculate the frequency, and vice versa. If you know the frequency, you can calculate the period. The relation is very simple. You can look at it at the end here of the slide. Frequency is simply 1 over the period, or period is 1 over the frequency. Now, to understand this in an easy way, let's say there is a wave which has a frequency 2 hertz. So what does it mean? It means that each second there are 2 cycles, 2 vibrations in 1 second. So one vibration will take half a second. So period will be half. So if the frequency is 2, then period will be 1 over frequency, 1 over 2, and so on. Now we have another question. Let's say there's a pendulum that's swinging back and forth, and that's a vibration with a frequency of about 0.1 hertz. So that's the frequency. So the question is, what is the period of the vibration? Well, if you think about it, it's an easy question. Let's first try to understand what is the meaning of 0.1 hertz. This means the pendulum is swinging back and forth. Each second, it is making 0.1 of a cycle. So it doesn't complete a cycle, just a tenth of a cycle. So, what is the time? How much time is needed to make one complete cycle? If you think about it, the answer is very simple, 10 seconds. Now, mathematically, this is easy to calculate. If we call the period t, so period will be 1 over frequency. Now, the frequency is 0.1 hertz, and that will be 1 over 0.1, which will be 10 seconds. Now we finished this part, and we have 2 questions to ask. The first question has already been discussed in the slides. What is the source of all waves? Go back and look at the answer. A second question I have here is saying, if the frequency of a wave doubles, what do you think will happen to the period? Think about it, and let's talk about it in class.